Hello to everyone. Let's go. Please put your headphones okay on the green channel. Thank you so much. Please welcome David González, lead Android developer from Mixed Hills. Thank you so much, David.
Hi, good morning. It's really weird talking to somebody on a headphone, but I hope it's all right. Yeah, my name is David, and I'm here to talk about Unidirectional Data Flow. And it's a very opinionated approach, and I think in terms of architecture, there's always a little bit of, there's many options that you can choose from, and doesn't mean that this is going to work for you. It worked for us, but I think the idea is that you get something from it and maybe get inspired and try to do things in this kind of way. And as I said, architecture is something that's very opinionated. I live in Belgium right now, so you have Instagram. Please follow this ugly Belgian houses account. It's, yeah, this is it. Basically, that I kind just find houses in Belgium that have very weird architectural taste, and the whole idea is to show them off. And it's a bit of it's similar to what we're talking about here today. Every architecture works. If it works for you and your app does what it's supposed to do, and your users are happy and your bosses are happy, then so be good. So if someone is happy building a house like this, then they should do it. And it's also like this. Or if you have an angry neighbor and you want to just do something like that as well too. So it's basically, these are very, it's very up to debate and up to your team and you how it works. And that is, I lost the best one for all. Really like that one. Basically, what we're going to see today is the experience from when I took over the Mixtiles app. It was done as it was, and everybody, they do the best they can to do their job. And there were issues when we tried to start doing modifications on that code. So we had new features that we wanted to build, and it was quite hard to modify the code that exists in code, refactor it, and then be able to achieve the goal that we had. And we were looking around, so how do we approach this? What is the architecture that should be followed? What are the principles that we want to follow? And Unidirectional Data Flow has been around for a while, and we were definitely not the first ones in try to implement it. And we started looking around different people, and I want to just thanks to these three fine folks, Fernando, Cesar, and Fabio. I think Fabio was around here. I didn't ask him for the photo permit, so I think he'd be okay with it. But basically, we were looking for documentation of how to implement this sort of architecture, and then we came up with the post from Fernando, Cesar, and Fabio. And we kind of took different ideas and different approaches from how they did it, and then worked together to try to do something that would work for our use case. In essence, Unidirectional Data Flow is a very simple approach. All you have is, there's a view that in your case could be an activity or a fragment. It's simply, the idea is that has an action that can be something that the user is prompting, something that comes from the system, and that action is sent to the view model that has the only job to interpret that action and make sure that he calls an object called a reducer that will bring you a new state. And in the end, the premise is the most important object of our whole architecture is the view state that we're going to be rendering on screen. And that's something that will hold all the information that we need, and we'll see a bit further how it works. This reducer is part of a store, and this store will dispatch that new state that we've acquired. We'll send it back to the view model. Then I will make sure that notifies everyone who's interested in that new state, so they can take care of that and display the information on screen, or react to the events that come from that event, from that state. That is the essence of how this flow works. The idea is it starts in one place, goes to the end of your business logic, and then comes back in a new state. It's very simple. In terms of who can bring these actions to the system, we have obviously the user. So the user will have an action like clicking on a widget, clicking on doing some action like pull to refresh, or trying to interact with your UI. We also have things like a push notification that comes into your system. And there's also an entry for maybe it's you just navigating to a different screen, or it's maybe updating information on screen. But that also will create an action that the view will receive. And then obviously the Android framework. because in simple examples, you don't really see things like that. But in our case, for example, we had to implement a payment gateway. And there are things that we have to listen for URLs from a specific payment provider. And that is an action in the end that we want to take care of. So here was a web view that was creating that new action. But essentially, any lifecycle aware component might be able to create an action that then we need to take care of. And obviously, then the view or fragment will need to go and send that action back to the view model, so they will take care of that. Actions are something as simple as something like this. Seal classes are we thought about that was the best approach to kind of module how to display what information we're taking care of here. So the actions can be something navigating to a new screen. When you press a button, you move to a new screen. Or actions that are more business related, like selecting an address, canceling another tracking achievement. Those are things that are very distinct in themselves, so they thought the best way for us to implement it was using a seal class. This action comes to the view model. Here we are extending the view model from architectural components. It brings a lot of good ideas and benefits that we don't have to implement ourselves. So we want to take care of that using the Android view model. Each view model will have a store. And that store is the one that will be taking care of dispatching those actions to the view. And what we have is we expose this observe function that has the live data component inside the store. And that live data is the one that's going to hold the state that we're going to be representing on screen. So we expose this observe function from the view model. And we want to know that every time that this is going to change, we're going to notify the observers. And then we get the new values. Similar for syntactic sure, basically, we get this interpret function because we want to make sure that everyone that extends that view model will have to implement the interpret function. We want to make it simple for everybody to have the same function are called everywhere in those view models, so it's easy to then read the code in different view models, right? And the benefit that we have with the view model from architectural components is that we have this unclear function that allows us to cancel the jobs that are going to run in the store. We'll go into a bit detail later after what does this cancel in the store mean. When we look at how that view model talks to the reducers, in a sense, we have this action that we just saw and represented as a seal class. It will go to the view model, and the view model decides, right, what is the action that I'm trying to do? What do I need to do now? And it will then call the reducer, and the reducer will be used by the store to dispatch the state back to the view model. If we look at the store, we have an initial state. It just makes it easier for us to start doing things when the store is created. And as we said, we have a mutable live data that is going to be the one holding that information on screen. We just apply the new state. And the interesting part of this class is this dispatch state. We want to make sure it runs on the main thread. And all we're doing is just updating the value of the live data. That's all we do. Now, this is the easier thing to display here, but in the end, we want to take care of asynchronous and concurrency, so we need to do something about threading. What we do is the store has a scope, has its own score, a coroutine scope, and basically what we want to make sure is that everything that is running in the store is running on its own coroutine context, because the store can be called by different reducers, so all those jobs are going to be defined as children coroutines from the main scope from the store. And we want to make sure that any of the jobs that are running inside the store can be canceled when the view model is going to be cleared. So what was the definition of this cancel function that we had earlier? What we're saying is we define our context as being in dispatches.io, so everything will happen in the background thread. And we want to make sure that we have access to the value of the states, and we also want to make sure that when we dispatch a new state, what we're doing is having a suspend function that's going to be the reducer. So we want to make sure that that is going to be suspending. That will do all the computation that needs to be done, and it will go back to the store when we can do it. So basically, we're launching this function, we compute the state, and then this reducer function is going to be then dispatched through the main threads to the view model that will receive it and send it back to the view. That is the whole idea of this approach. Does it make sense? Others? Yes. So How does the reducer look? It's a very simple, we're going to have more difficult examples, but this is the simpler one to start with. The page reducer, in our case, page screen is the first screen that you see when you open the Mixtiles app. And we want to show some testimonials for some influencers. I want to make sure there's a pricing object to tell you how much the tiles are going to cost. We overload the invoke operator just because it's just nicer to read than not doing it so. And we just have this wrapper called state that we'll see later in a bit more detail. It's just going to wrap the page, which is the view state, and it's going to be the one that we send back to the UI. We just say this load page will be called by the suspending function in the state, and we know that everything that is going to happen in this function is going to be on a background thread, and we just return it as a new view state, which has a list of testimonials and a pricing object. This is how we would look on real life. We have a pricing, and then we also have a list of influencers that we're going to be displaying all the artwork that they have at home. In the activity, which is the part that we use to connect with the view models, we have this observe function with a lambda reference to the render view states, and this is simple. A function that will do a when on the type of view states, and it will decide based on the view state that we receive, it will just call the render function to do whatever it is. In this case, we'll be setting up the view pager and also setting up the text views that we have in the screen. The view model in this particular case has this reducer, and what we do is we interpret the action and we decide, well, based on the action that you're sending me, what am I going to do? And then if it's load page, will be the initial action that we receive when we start the screen. We just call the store, we dispatch the new states in the form of the reducer. And to make sure that we're not doing anything that we are not supposed to do, if it's not the action that we want to take care of, we want to make sure that we are throwing an exception that we capture on the UI side, and we have to deal with that. But this is a very simple approach. It doesn't have it's not very complicated, right? It's just displaying a list of things and displaying a pricing, and that will be it. But how do we do with a more complicated view state? What if we have, we have errors that we need to display? What if we have multiple errors that we need to display? Maybe this approach is not good enough. So let's see. This is the screen that we show when you've completed an order. You have your different tiles, and you can also change the address that you want the tiles to be delivered. This is a typical form where we want to call our API. We will ensure that the address is a valid address, so we can actually send you the tiles to your home. And here we see one of the errors. Well, the postcode of Torino is not 3511. That's the one of my house in Belgium, and therefore is not a valid postal code for Italy. And here what's happening is when we interact with all the UI, we want to make sure we are loading. We want to display that we are showing a loading state, and then based on that state afterwards, we'll see when I display an error, or we want to display the finishing screen that the address has been changed. How does that look? But this is not as simple as before, right? We have the actual order, then we also have error flags that will tell us if it's the wrong city, country, or address. We also want to know if it's loading or not. We also want to know if it's completed, and we also want to know if there's an exception. So in here is just a bunch of stuff that they are related, yes, but they are not really the same. It doesn't make sense that they are all the same object. How does that look, though? If we call the render screen, then we have if and else's all over the place, right? We have if the state is completed, then we render that state. If it isn't completed, then we show, are we loading something? Let's display the progress bar or not. Is there an exception? Then we also have to render the exception. And if there is some visibility for the errors, then we also take care of that. But in the end, this code is more like a very long function that does a lot of different things that are not completely all related, right? So how can we do this? This is how the action would look like. In this case, just to showcase how it would be, we have options to navigate to different screens, but we also have options to interact with the screen that we are on. And the view model gets a bit more complicated than before. Now we have 3 different actions that we need to take care of, and then we just need to make sure that the store and the navigator in this case that is a class that would navigate to another screen is also used. But the problem here is we want to make sure that we can load. We want to display a loading state. And here, a coroutine only returns one value, right? So we're not going to be able to do it like this. So we now, just to run, to work around that, we need to dispatch two states, in this case from the view model. We have one for the loading and one for the actual action of changing the address. So this is not really optimal. Also, navigation events are not really a view state, right? You're not displaying anything in that screen, you're actually moving to a different screen. So how can we handle it? As we said, the view model is being called twice. It's calling twice the store to display two different states. So there's something that we could be doing better. So here's where we start introducing new concepts, and the first one we want to introduce is a class called either. Don't worry, I'm not going to be another Spanish guy talking about arrow. This is just a reference for the documentation. This is very well done. It has a lot of proper videos explaining what this means and proper text documentation about it. Basically, either is very useful for us in this case because this is going to represent two paths, like a happy path and a failure path, a success or a failure. And this is going to be helpful for us to then be able to model our data and to properly explain what are the paths that our application and our screen are going to follow. We have a left and we have a right. By default or by convention, we dictated that either is the left is used for describe a failure and the right part of it is described to use a success. Knowing that, we're going to start modeling our screen and our business logic following this approach. So if we talk about the failures, we have app-wide failures. We have things that are common to all the screens in our app. For example, from the networking layer, we can have a server error. We can have a connection. We are not connected to the internet, so we want to ensure that this is also described as a connection error. We can have different types of errors app-wide. But we also have feature-specific errors that we want to describe. So if you were here yesterday afternoon in Eugenio's talk about Kotlin, you'll see that this SIL class, everything that is the direct children from this failure class need to be defined in the same file. That's the error, the connection, and the other error. But if we create an abstract class that's called feature failure, we can define those SIL classes in another file. That's going to help us showcase how our data is going to be modeled. So in our view model, on our model class for a specific feature failure, we're going to define specific failures for that specific screen. So we don't have to go back and forth different files to find out. And it will be crazy to have a SIL class in one file with like probably 30 or 45 different failures, right? So we're going to model it that way. And we're going to take the same approach for the success. We have now a definition of view state and view event, because for us it makes sense to define them as different objects. But we also have app-wide success events and states. So like being idle or being loading some data. It is the same loading one screen or loading another type of screen. In the end, it's a loading states, and it will be the UI side, the one that will take care of modeling and rendering that information as we want. So with this new information, let's see how the store would actually look like. We still have the same. We have an initial state, and we also we have to implement our own coroutine scope. What we're doing here now is our live data, it just has either one failure or one success. Very similar to what we had before. Same as the suspending function that's going to be the one returning the new data is going to return either state of failure or a state of success. And the coroutine code is going to be also very similar. Basically, it's going to just render, reduce the state, bring a new one, and send it back to the main thread, to the live data object. How does the main view model though? And that's the big difference that we had before. Now we have two live data, one success and one failure. And the reason for that is whenever we're recreating this screen, we also want to make sure that we have both last states. Because based on the screen and based on how the feature is going to work, we might want to have access to both of those last states. What was the last failure that we had and what was the last success? So by doing so, we know that whenever the app is going to be rendered again, we can always get back the latest objects from live data and decide what to do. The observe function changes a little bit. Now we have two observers, and those are going to be the ones that observe on the new live data objects. So therefore, when we call the live data object that we still have on the store. That's going to be the domain object, let's say. And that's going to tell us, right, am I at left or am I right? Am I a failure or am I a success? That sounds really weird when you say it out loud. But the point is, whenever we know what sort of situation, what sort of path our app is following right now, we then will decide to update the proper feature values of the proper live data values of our view model. So if we go back to the original data class that we had in this screen, we've seen that we have all those different flags with the orders and the loading and complete. If we look how that file looks now with the new approach, it looks a bit cleaner like this. We have a data class which is going to be the order. That's the state of success. We also have two events, talk to us and address changed. That means that when someone clicks on the chat icon, the reducer will return a new state, returns an event in that case, which is still a success, but it's an event, and we want to model it differently. And we'll also have the one for the address changed. And then in case of the errors, we have a feature error, which will be the invalid address. And that is an object that represents a failure on the invalid address, and then the UI will take care of displaying this as it's convenient. In the activity, we now have the two observers, so we have success and failure. And this is how it would look on the activity level. So we have a success, and we can always do the when on this sealed class, and we have to decide, right, do we want to show, do we have an event, then we have to react to it, or we have a view state, and we want to render it. The render is very similar to what we have earlier, so we had orders or whatever other view states we will have. The code is the same. We have to react to the order, we show it, and then the event side, then it gets more complicated. Those events are not something you're going to display on screen, are going to stay forever. The main idea is this is a one-off kind of thing. So say like the address change, we want to show a snack bar when the order was canceled. We want to either that or navigate to a different screen. So it's just more like syntactic, sure, compared to what we have earlier, but it's easier to read and it's easier to understand what it would do. And then the thing happens with the failure. Now this type of failure, we only have one. So we just take care of this, but it will be the same code. We just have to do a when and be able to dissect that failure and decide what to do on those things. But sadly, we haven't solved all the problems yet. Imagine this screen. This is the screen where we want to complete an order. So we're going to check out. We have an address. We have a payment method. And we have this progress bar that's being shown. That progress bar is telling us your photos are being uploaded, so we can then go and print them. And we want to make sure that the progress bar is an actual representation of how far your photos are being uploaded, the actual progress of the upload of the photos. Therefore, we need our business logic to tell us several times to update the UI. It's not just one object, it's going to be a series of objects. So for that, we started to think how we're going to implement it, and we had the idea to talk about coroutines. But it's a very funny moment because since yesterday afternoon, those are deprecated completely. So I didn't have time to change everything, but at least it's going to be the idea to explain how this works. So JetBrains has now released Flow. It's in the alpha since yesterday afternoon, and it completely changes what we are having, what we're going to show in a moment. The idea is that channels are hot streams. Hot streams means that you need to have two sites connected to that channel to receive information, right? A stream that is hot needs to have two parts connected so the data to be interchanged. Our example, for example, is the cold stream, which means that you don't need to have someone observing on that stream. You just have to do it, and the stream will be sending data through the stream, and then if there is someone connected, you will receive the data. If there isn't, data will still be computed. So yeah, I'm sorry that everything you're going to see now is deprecated, but I didn't have time to change my slides or my code, so you're going to have to deal with it. But the idea is still, it's still applicable for the future. In channels, the main idea is the FAIR only allows you to bring one single data back, right? So one-off object. With channels and with streams, we're able to decide to send different values, and then we can start operating on those values. So channels implement the two interfaces, send and received, and both of those options are going to be used for different things, right? So let's see how a very simple example. Channels by default, they have a capacity that you can define, and based on that capacity, the objects will be sent. For example, if we here have a, whoops, doesn't want to work, fine. All right, thanks, now. So we're launching a channel. We're going to send from 1.5 different events to that channel, and at the same time, we're going to have a, this is great. It's the first time I'm using magic moves, so I'm sorry about this. Basically, what we have is two coroutines. We're sending objects to the channel, and we are receiving values for that channel. And what we're trying to do is whenever one is used in the first coroutine, the second coroutine is going to consume that, that object, and then in this case, we're just displaying them on screen. That'll be the simple approach. This is great. There you go. What do we also have? Same as launch and async, we also have an extension function that produces a channel. So we can use this to create a receiving channel, and it will take the build that is a suspending lambda as a parameter, and only the code within that lambda can be can send items to the channel. So in example, we'll have this producer. We will define the capacity is 2. And what we're going to do is for same code before, for every number from 1 to 5, you're going to send it to the producer. It's going to be the channel. And then on the other side, we have a coroutine that's going to listen to that channel. It's going to consume each one of those events and ensure that we are receiving it. In the end, the outputs will be the same. So how does that look in our case? We're going to define the extension function in our reducer. That's going to take that lambda, and we're going to be able to send it to the producer scope to be able to send states through our stream of data. And then we have a function that's called produce state. That's going to be the one called from the store, because we want to make sure that we are now using here this global scope produce. So we're creating a channel, and we want to be able to execute that lambda through the channel. So all the events from that suspending function are going to be the ones sending data through the stream. The store changes a little bit as well. We now have more than one state, so we have this receiving channel. What we're trying to do is every time a message or a object is sent through the channel, we consume it, and then we ensure that from the main thread on the main dispatcher, we are updating the value of the live data. How this looks from the view model point of view, we have these loading orders where we're just dispatching states, and these get orders will be the reducer that's going to show it. So we have the reducer here. It looks exactly the same as before. The difference now, we have this receiving channel, and we have the produce states exception function that allows us to create the channel. And the code looks like this. We send one event, loading, and this is being sent to the channel. Then the view model is receiving that, and it's going to start taking the state and sending it to the live data to the view. We do our operation. We are getting, in this case, list of orders. And then we send another state through the channel, which is going to be taken care of on the other side. And that's how we solve the issue. Instead of having to send through states through the view model, we have now a channel that's going to be sending all those states back to the main UI. In terms of testing, this architecture of how we've done has, we're going to show UI tests on the activity of fragments. Basically, since we've abstracted ourselves from the view model, we can just have a wrapper on the object on the activity class, and we can just start rendering states. We don't need to connect to anything else. We can just isolate those tests in the activity, and we just render different view states and ensure that the activity is shown, the UI does what we're supposed to do. On the view model, we have unit testing to ensure that the live data are being updated as supposed to, and integration test. And then on the reducer, we have unit test to ensure that the data are being sent, and instrumentation test with the whole thing. What we do need, though, is a way for us to test all the objects that are coming through the channel. What we have here is fold is an option that allows us to, so we're going to, using fold, is going to accumulate all the different values, and it's going to start applying all those operations from left to right to the current accumulator. That means that if we do something like this, there will be a test of the reducer that we saw earlier. We expect a state with different orders. We expect that when the repository is called, we're going to return a list. And then we have this run blocking is going to say, well, after this, every single state that's being called through the reducer, you're going to be accumulating it in this list. And then we can operate on those lists and check and assert that the value is what we want. I'm sure we could clean this up a little bit for this either right and left to not be in all the tests, but that was the main idea for now. And same with the error case. We have an exception. We can assert that we throw it, and that's how we could go about it. Now, what's next? Obviously, a few things that we can be yesterday. After watching Jose's talk on the new things on data binding, I think all these dance that we have in the activity with render success, render failure, and view states, I think we could do better defining those things as data binding in the layouts, but that's something that we need to see, at least just to clean it up. And then obviously we have this long-term issue in coroutines about the hot streams. Obviously now it's all deprecated, so probably the next week we'll be working on how to implement the same flow on using flow and see how we go about that. But that's all I had. Thanks.